like. All right, so I am recording. As a reminder, and you have plenty of practice with these, just make sure you're practicing. You can even go online and just ask and do a Google search for just basic metric, system conversion problems. Focus on milligrams, grams, micrograms, milligrams. You don't really need to worry about going from grams to kilograms, micrograms to kilograms and things like that. You don't need to worry about decimeters and decigrams and deciliters and things like that. You will talk about deciliters when you get into the different types of blood chemistry stuff, but for dosage calculations, you won't need to worry about that at this level of your nursing career. Later on, you will get into more specific types of things that will have a that will have an effect on darn it, I just forgot what I was going to say. Will have an effect on the different types of medication and populations that you're working on. So, okay, good. I see there's some half-life questions, so I'll get to those in just a moment.
Yeah, I just
Perfect.
put those in the chat so I didn't forget. Thank you.
Perfect, thank you. Okay, so again, just practice your metric to metric conversions, practice your household or your imperial units to metric conversions, as well as your metric to imperial, if that were to be the case. Most of the time, you're going to be doing imperial or household conversions to the metric system because it's the metric system that you're utilizing within the medical field. So we talked last time, or we talked a couple of times. Just remember, a lot of times they'll tell you if it's a glass and how much that glass holds. So if it's a glass, glass is 8 ounces, and if it's a quarter glass, 1/4 of 8 ounces is 2 ounces, and then you can convert ounces to milliliters from there. Sandwich isn't liquid, popsicle is liquid. There's a little bit of nuance between like Jello and ice, but I think Jello is the same thing as a popsicle. It was just ounces to ounces. Ice is a little bit different. So just make sure you get some clarification on what you need to know as far as ice. I believe I've read that if it's 4 ounces of ice, that's the equivalent of 2 ounces of liquid. Don't quote me on that. I just I vaguely remember seeing that. My hope is that they wouldn't even talk about the ice component. They would just say, what they want you to calculate. So here you can see, like someone asked last week about Jello. You don't need to know like how much a gelatin dessert is, like how much is in the container, because that could vary. It could be 2 ounces, 4 ounces, 6 ounces, 8 ounces. It really just depends on the container. And if you made your own Jello, you could, you can have a gallon of Jello, I guess, if you really wanted to. You would, but it would need to be given to you the number of ounces in order to calculate the milliliters. You wouldn't just assume that every hospital is the same, for every feeding situation is the same.
Can we just go through one of those questions that I know? Can we just like break it down?
This right here?
Yeah, or either or, whichever.
Yeah. We'll go ahead and let's do this one here, the second one. Okay. So I have a new tool that I'm going to try here. We're going to see if it works. All right. So when we get to the 6 ounces, whoops, we know that 6 ounces, 1 ounce is what? Is 30 milliliters, right? Good. So what I'm going to do is I'm going to take my 6, if I can write. Sorry, I have a pen here that I'm trying to use. Times 30 gives me 180 milliliters. Okay, so that's part 1. Then for the 2 ounces, I'm just going to do the same thing. I'm going to say 2 times 30 gives me 60 milliliters. 8 ounces is 8 times 30. Is 240 milliliters. Oh, great. It turned colors on me. I didn't do that. Okay. And then we have 2/3 cup that is going to become, so we need to know that 1 cup is 8 ounces. Then if we know that 1 cup is 8 ounces, then we're going to have to figure out, okay, well, what's 2/3 of a cup then? So you might have to do a little bit of math. 2/3 times 8. It's going to give us a weird number here. And I'll actually show you another way that might be more helpful. So you can do it this way. And all I'm going to do is I'm going to take 2 times 8 and divide it by 3. And you're going to get 5.33333 repeating. And that's 5.3333 ounces. Multiply by that by 30. And that'll give you 159.99999 repeating. You're just going to go ahead and say that is the same thing as 160 ounces. The other way you could do this, and the way that I probably did this when I originally put this kind of question together, is I'm just going to come down here. I took 1 cup is 8 ounces, which is the same thing as 240 ml. So, sorry. So 240 milliliters. And if I do 2/3 of that, that's the same thing as dividing by 3, multiplying by 2. And when I do that, I'm going to get the same answer, but there won't be any decimals. So 240 times 2 divided by 3 gives me 160. It's the same answer. So then all you would do then is once you, oh yeah, I apologize. I wrote 160 ounces here, and that should be, let's see if we can erase. Oh, that's because it's using a different annotation tool. Anyways, that should actually be 160 milliliters, not ounces. Sorry about that. So you would just add it up. 180 plus 60 plus 160 plus 240. So 180 plus 60 plus 240 plus 160. And then you would get a total of 640 milliliters. And that is how much volume that they would be bringing in. Now, again, I apologize for the scatterness. Like I said, I got a new tool and I'm trying to utilize it, and I'm still learning the ropes on it. All right, so let me move on. Should be able to. Okay, that'll stay there. All right, the next, we did a couple of these. Are there any of these that you feel like you need to review again, or do you feel pretty good about any of these?
Can you do that one, the Zofran?
The Zofran, sure.
I think my biggest concern is for me remembering how many like teaspoons, tablespoons, all of that, because that's what I missed.
Okay. Yeah, so yeah, okay. So like this one tells you it's the teaspoons, and you need to know, okay, well, what do I need to know as far as teaspoons, tablespoons? So the question even tells you how many, how many milliliters will the patient receive in one dose, so that it does tell you. If it didn't tell you, then technically you could use milliliters or teaspoons, but since it tells you that, now you know what you're looking for. So the other thing is we're going to look at our order. And our order says we have Zofran 10 milligrams by mouth 3 times a day. We have Zofran in a 100 milliliter bottle. That just tells you the quantity. So I'm not going to use that for calculating how much I need to administer. What I'm going to use is this. So this is my order here. This is what I have available. And then the teaspoon is also what you consider your quantity. So another way, and we know, and just as a rehash, what does 1 teaspoon equal?
For milliliters?
Yeah, in milliliters.
15?
Not 15.
5?
5.
See, that's what I'm getting mixed up.
Okay. So weird question. This has nothing to do with you being a woman or anything, but do you cook?
Absolutely not.
Okay, fair enough. Okay, good. I do cook, but I'm sure somewhere in your kitchen you have teaspoons and tablespoons. If you do, get in the habit of looking at them. So like, let's say you have coffee in the morning and you're adding sugar or something like that. You might use a teaspoon to add it, or maybe a tablespoon. I don't know how much sugar you're using, but take a look at your teaspoons and tablespoons the next time you open up that drawer or look at those things. Even if you never use them, it'll say right on there, 1 teaspoon, 5 ml, 1 tablespoon, 15 ml. And the only reason I'm telling you to do that is because sometimes it's helpful to connect it to something more realistic than just having to memorize it.
Okay, thank you.
You're welcome. And then just since we talked about it, a tablespoon is going to be 15 milliliters. All right. So what I'm going to do is, I know that 1 teaspoon is the same thing as 5 milliliters. So I'm just going to replace teaspoons with 5 milliliters. And I'm doing that mainly because milliliters is what we're looking for. Okay. So I'm going to use the order over half process. So I'm going to take my order of 10 milligrams divided by my available, which is the 4 milligrams. And I'm going to multiply by my quantity, which is the 5 milliliters. So I'm not even going to worry about teaspoons. I'm just going to leave that out of the equation. I'm not going to add it to make things more difficult for me. 10 times 5 is 50, divided by 4 will give me an answer of 12.5 milliliters. So again, this is where like practice. So you could change this question and even say like 4 milligrams per tablespoon, and practice solving for milliliters that way, just to add some extra practice.
And we would not round 12.5, right?
You mean you wouldn't, right? You wouldn't round it.
You wouldn't round it.
Right.
Okay.
Yeah, for most, when we're in like these medications, like when we're doing actual calculations, think about when you are administering, if you're using a syringe of any sort, so whether it's an injectable syringe or an oral syringe, you can usually they're down to the half milliliter or even to the 10th milliliter, which is why you can keep your volumes at the 10th. So for numbers, this is excluding your basic unit conversions for numbers that are greater than 1, round to the nearest 10th, numbers less than 1, round to the nearest 100th. And this would be an example. And you don't need to round because it comes to the nearest 10th. And so you just leave it alone. It's a good question. See, and you would do the same thing with this one, but it's 50 milligrams per milliliter. So there's no teaspoons or tablespoons to worry about. Sometimes it might ask you how many teaspoons to administer, but this one is just asking you about Benadryl. Then you can see this is an injectable Benadryl. So intramuscular as needed for itching. And then you can see on your syringe, it has increments to the nearest 10th. So that's another thing that kind of helps you out with, you'll know that when you're marking the syringe, you know that you're probably going to need to utilize, or that you can keep your answer to the nearest 10th. So like for this one, let's just solve this one out real quick. So my order was 65. My available is 50. And then my quantity is 1 milliliter, which gives me 65 divided by 50. It gives me an answer of 1.3 milliliters. So I'm going to write that. Just going to scroll down here a little bit. I'm going to write that here, 1.3 milliliters. And then I'm going to come down. And since I know my answer is 1.3, oops, sorry. I'm going to look for, here's 1, 1.1, 1.2, 1.3. And so I'm going to go ahead and draw. And it tells you to shade it. So you probably want to shade that all in. Again, you'd be able to do a better job than I am with my pen here. Sure, there's a way I can just double click and shade it in, but I don't know how to do that yet. When I leave these little swirls, it looks like a child was helping me do this. So you're going to do the same thing for heparin. 10,000 divided by 7, or I'm sorry, 7,000 divided by 10,000. Because it's in milliliters, you know, you're looking for milliliters, and then you would just mark it on the syringe. Last time, or on Thursday, we talked a little bit about insulin, and we know, like, basically we look at the number, it says 315. We look at the range. We see that the range that 315 falls into is this one right here. So we're going to give them 8 units. This is what I was babbling about earlier, about the deciliter. So you'll see deciliters as part of like glucose and other electrolytes in the blood or nutrients in the blood. They're usually measured in deciliters. So that's where you'll see that. But you're usually, from a medication calculation, you're not usually administering deciliters. It's milliliters or it's liters, depending on what we're talking about. Usually it's milliliters, by the way. When mixing an insulin, here it just tells you how to, that the nurse had taught the patient how to draw it up and self-administer. We want to know what the amount of insulin the patient should prepare in the syringe for the total dose. So this one's pretty straightforward. You're just adding 18 and 14, which is 32. And then you would just mark 32 on your syringe. And they tell you to shade the dose, so just make sure you shade it appropriately. Remember, your unit for insulin is going to be units. And then I thought I had a reconstitution question on here, but I don't. Let me just see if I had one and I went over it. May have. Went past it. Maybe not. So I'm still working on a few of these. let me just see 1 second. Oh yeah, here we go. This might actually be the practice test that I'm not allowed to share with you in its entirety, but I want to show you what a because this is the one that was tripping everyone up last semester, was the this one here. Nope, not that one. This one. So this is a reconstitution, and I think I went over this last week too, because I don't know who comes here, but one of the things that can happen when we look at this is the first time you're seeing this, a lot of times you don't know what to do with the information. You just know, okay, I know ordered over have, and I know I need to know a few pieces of information in order to do order to have, but sometimes you don't know everything, obviously, that you need to know. And so one of the things, let's see here. One of the things that you might run into is like, you'll see this sort of setup and wonder like, okay, well, it says, it says 1 gram, but what do I do with that? What do I do with that 1 gram? And so what you need to do is you need to look at the rest of the label, because the rest of the label will tell you how to get to what you're looking for, which is you're looking for milligrams per milliliter. That's your goal. Where is that? And so you're going to look at the label, and it's going to tell you to add some water, sterile water. Okay. But again, that I don't really care about that. That's just telling procedurally what to do. And then it tells you it's going to give you an approximate volume of 3 milliliters. Still don't care about that. But what I do care about is this right here. You see where it says 330 milligrams per milliliter? That's what you're looking for. That's your concentration. That's your available. Okay. So you can ignore the 1 gram. You can ignore the 3 milliliters, 2.5 milliliters. There's nothing else really here that's going to be helpful for you. You're looking for this here. It's just the unfortunate thing is that it's like tucked away on the side label. And so you'll see, and I also shared a couple images of different reconstitution problems. That way you can see what that looks like. And so when you're solving this, you're going to take your 550 milligrams, which is what was ordered, divided by the available, which is the 330 milligrams, times your quantity, which is the 1 milliliter. And then what you're going to get is 550 divided by 330. You're going to get 1.66666666. When you get a number like 1.6 repeating, so 1.6666, and it just keeps repeating, you're going to go ahead and round that to 1.7. So that is where you would round. Okay, so if you're ever wondering when do I round, it's when you have a number that is repeating like that. But I'm not going to round that to 2. I'm going to round it to the nearest 10th. So how much medication will they receive? They're going to receive 1.7 milliliters. And then you would mark that on the syringe. You would look at the syringe. You'd see this is 1, 1.5, 2. So 1.5, 1.6, 1.7. And then it says to shade the syringe. So I'm just going to shade that in. And like I said, there's probably an easier way for me to box and shade, but that'll do for now. So again, these are just some of the problems. I'm still working on putting a few practice problems together. I know that your test is in 2 weeks. Is that right? 1, 2, maybe it's in 3 weeks. Do you guys remember the day of your test?
October 8th.
October 8th. Yeah.
Say that again.
It's October 8th.
Oh, okay. So it's on a Saturday. Okay.
Yeah.
Okay, so yeah, so we'll still be getting together on Thursday and then next week on Tuesday and Thursday, and then the following on Tuesday and Thursday. So you just want to keep practicing these problems. And then, like I said, over time, you will continue to get better. Like I said, I know I've said this probably since the beginning. If you've been coming here for a little bit, I keep saying I have more practice problems for you. I do. I just keep forgetting to add them to the folder, or at least to put them together. But now you're at least seeing this version. Like I said, it's not your test or anything like that. It's just, it looked a little too similar to your test, which is why I'm not sharing it. And everything else is pretty much, oh, this is actually a different same type of question. It's a what's it called? Reconstitution type of question. So what I'm going to do is I'm just going to let you take a look at that, and go ahead and take a few minutes and see if you can come up with the correct answer. And when you know it, just type it into the chat. Take your time. Remember, you have to look at the label to find the concentration. And you might already know all this stuff, and I might just be wasting your time with it, but maybe it'll be helpful. And I'll check the chat to see. Okay. So just, oh yeah, there's some other people here. So I got the first answer. And then I'm taking, if there's any other answers, I'm taking them. I'll give you just a few minutes or a few more moments here. All right. So the first thing we want to look at is our order. 250 milligrams IM every 6 hours. Then we see that we have 500 milligrams, but remember, that doesn't really tell me anything as far as figuring out how many milliliters to administer. So I have to look at the label. And so that's your if you're looking and it says intramuscular, immediately you should be thinking you're calculating for milliliters, and your label should say milligrams per milliliter. If it doesn't, that's your clue that you're dealing with a reconstitution problem. The other thing is, it'll even say on the label before reconstitution. Okay, it tells you the usual adult dosage is 250 to 1 gram every 6 to 8 hours. We're on the low end of that. We're fine. For intramuscular administration, add 2 milliliters. Again, you can ignore that. And you can see it provides an approximate volume of 2.2 milliliters. You can ignore that. What I'm looking for is this right here, the 225 milligrams per milliliter. Okay. So what I'm going to do is I'm going to take my order, 250 milligrams. I'm going to divide by my 225 milligrams per milliliter. And then I'm going to get an answer. And the answer I got was 1.1 repeating. So 1.1 milliliters. Now I did see that you got 2.2. What numbers were you using to get to that answer? I just want to make sure. Correct. Yeah, the 500 doesn't tell you anything. That just tells you what is the amount of powder that's basically in there. But what we care about is the concentration, which is right here. That's what's weird about the reconstitution. So that makes sense. So if you did, if you use the 500, then it'll definitely, you could factor that in. But the 500 is not the order. The order is the 250. So good. And that's helpful. This is the place where, you know, with me, this is where you want to make these mistakes. And then you can see, like, where am I getting this information, which is why I asked you to try it on your own, just to kind of see how you did. So if you're doing this on, you know, any of these that we're working through that you don't have access to, if you're, you know, looking at it on YouTube, you can always go back and, you know, pause it at the point in which, you know, before I go through the answer, and then just see, can you get it yourself? You know, you can try this. What if the order was, you know, 375 milligrams every 6 hours? That's a whole nother problem. And you can practice that using 375 milligrams. So, all right. I think that was it. And then you would just mark the syringe, but I think we're good on that. All right. So let me go ahead and talk about the half dose as well, or the half-life. Let me just take a look at that real quick and see if I can help you out with that. I think I had here we go. My guess is that this should work out. So let me open up the chat box. I had a couple questions here. And when is this test this week?
Yeah, it's our NUR one. There's like one problem on this. It's on Monday.
Oh, okay. Okay, so it tells us a couple of things. Just says some drug has a half-life of 8 hours. So we know what the half-life is. Okay. If 800 milligrams is administered at 1 a.m., how much of the drug will be eliminated after 24 hours? So we can look at this dosage calculation here. Let me just make sure everything's within range. So, and I got this, I just went to omnicalculator.com. I'm sure this this formula is in your textbook as well. And so what I'm going to do is I'm just going to plug in the numbers that we need. So what we're looking for the dosage little t, because it says how much the drug would be eliminated. So basically we're looking for how much is left, and then, or how much is left in the body. So then we can then know how much was eliminated. So we're going to see how that works out. Our initial dosage was the 800 milligrams. So if I'm over here, oh, I guess I got to open this up. All right, so we're looking for the initial dosage, which was what we're looking for. So I'm just going to put a question mark here. We know that the initial dosage was 800 milligrams. We know that we're looking for the half-life, so 0.5. And then it says little t over big T. The little t is the time that has passed since the first original administration of the drug. So that's 24 hours. And then the big T is the actual half-life of the drug. And we saw that the half-life is 8 hours. So if you remember, now as a reminder, this is not on the dosage calc test, but this can be helpful just to know what to do with this. So whenever you're doing any kind of math, always do what's in the parentheses first, right? So remember PEMDAS, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. So always do what's in the parentheses first. So I'm going to rewrite this as 800 milligrams times the 0.5. And then in parentheses, 24 divided by 8 is 3. So now I'm just going to calculate. I'm going to take the 800 times 0.5 times 3. And I'm going to get, wait a second. Did I do that right? That doesn't make sense.
The answer's 100.
Okay. So I got my numbers are not working out properly. Oh, you know what? I bet you this is incorrect here. Oh, no, that's fine. I think this up here might need to be inverted. So give me 1 second and let me play with this a little bit. That doesn't make any sense. Nope. It's not working either. Did I do something wrong? So you got to 100. Got either. So 700 would have been, it said how much of the drug would be eliminated after 24 hours. So only, and the answer is 100 milligrams. So how do they get this?
Yeah, I don't know. I did 800 divided by 8 and I got 100. I don't know if that's the right way to do it.
Well, what's the answer for the second drug A? What is that? 600 divided by 4?
Wait,
was it 150?
It's 9.375.
Okay.
Because I did 600 divided by 4 and then I hit the equal sign twice. I guess that's 2 cycles. I don't know how they explained it in class. If anybody else in here like knows how to do it, please help me because I like really don't know how.
Okay. Yeah, if anyone has, because I'm struggling here a little bit too. So go ahead.
Oh, sorry. We did a question like this yesterday in class with Miss Petro. I'm trying to remember exactly what it was, but how I have it up here to get where she is, just if I could explain it, I have 800 times 0.5 brings you down to 400. So that's the first 3 hours.
Okay.
And then 400 times 0.5 is the next 300, the next 3 hours, which brings you down to, or I'm sorry, the next 8 hours. That's what I'm talking about. 8 hours.
Okay.
So that brings you down to 200. And then you multiply it by 0.5, 200 by 0.5 again, and that brings you down to the full 24 hours, and it's 100.
Okay.
I don't know if there's any, like, I'm sure there's an easier way to do it, but when we learned it yesterday, it was like, within 6, so I guess the half-life was 3 hours and the total was 6 hours, and it dropped it down. The answer was like 225, but okay. I can't remember the full question, but that's kind of how.
Yeah, I did the same one. I don't even remember if I have it. I did that same problem.
You know what I'm talking about?
Yeah, I might have it in my notes. Hold on.
Okay.
So I actually have a good explanation of what you just said, and that was actually helpful for me. So what is discussed here, the 24/8. So 8 hours is the half-life time, and the total time is the 24 hours, which means it's going to have a half-life every, or it's going to go through and decrease by that by half every 8 hours. Right. Exactly. So we know that the half-life is 8 hours. So how many 8 hours are in 24 hours? There are 3. So what you told me, which is actually what was helpful for me, is I'm going to multiply or divide by 2. So either multiply by 0.5 or divide by 2, and I'm going to get a half-life. So that's 1 cycle. So that's my first half-life.
And you do that 4 times, basically.
Well, for the first question, you would only do it 3 times.
Okay.
Right, because there's only 3 8 hours, and then we get 200, and then so that's the second. So this is 8 hours, then 16 hours, and then to get to the 24 hours, you're going to do it 1 more time. And that's where you get how much is remaining, which is the 100 milligrams.
I have that problem we did yesterday.
Okay.
So 300 milligrams at noon, 1200, and it has 3 hours of half-life. How much by 6 p.m., 1800 hours?
And what time did it start again?
Noon.
Noon. Okay, so it's and then and the half-life was 3 hours, you said?
Yeah,
So how many half-lives will it go through
until
by the
6
end?
p.m.
Right. So how many times will it go through its 3 hour half-life between noon and 6 p.m.?
I don't know. I know the answer we got. I didn't write the whole question down. The answer we got was 225. So I have 12. Noon, I have 300 milligrams. 3 p.m. I have 150.
Good.
6 p.m. I have 75. And
Okay.
then I guess they took 150 plus 75 and got 225.
Okay. Yeah, I'm not sure where the 150 is coming from.
I don't know.
That's what confused me, because originally when I saw that problem, my instinct said that the answer would be you would just divide 300, or I don't know. It just, I did not get it correctly. But then she said, so the first half-life is 150 and the second half-life is 75, because you want to break 150 in half. So 300 divided by 2 equals 150. That's where that 150 came. And then the second half-life would be because you divide the 150 by 2 and get 75. But then at the end, she added the 2 together to get that 225. So with that being said, does that change the one we just did?
That's what I'm saying. Like, that's a good question. Unless the question was being asked, like, because this says how much of the drug would be eliminated versus how much of the drug would be left.
I literally just pulled those questions from Quizlet.
Okay.
So, but yeah, this one that we're talking about was the one we did yesterday. I really don't like, people are doing it in their heads in class, and I'm just so confused.
Okay. So, well, first of all, like breaking, let's just look at these because I have them written down. What I'm getting at is, so if we know the half-life is 8 hours, and we know that there's 24 hours that the drug is in the system that we're concerned about, we're gonna, every 8 hours, we're reducing how much medication is basically there, or how much is being eliminated by half. And so when I ask how many half-lives has it gone through, you're just taking the time. So like the example you gave me between noon and 6, that's 6 hours. And if it's every 3 hours, then it's going to go through the half-life twice. So you would divide by 2, and then you would divide by 2 again to get to the final time that you've and then for this one, you're doing it 3 times, because 8 goes into 24 3 times. For this one, 4 goes into 24 6 times. So you're going to do the half-life 6 times. So let me just show you what I mean by that for this one.
Can I ask a question real quick? I'm sorry.
Yeah.
So I kind of remember, I thought originally when she just read the question out loud yesterday about that 300, in my mind, I thought the half-life of 300 is 150. The total is 6 hours. So it's going to be the full 300 is coming out. But with half-life, you have to, the first cycle, split that number, then the second cycle, split that number. And like you said, this is asking how much is eliminated after 24 hours. That answer would actually be 700, because you eliminated, the first half-life was 400. That was what it was eliminated. The second half-life was 200. And then the third was 100. So that answer for that one should be 700.
Okay. So you would add up
the
milligrams. Okay. That's where like this is a little bit confusing as far for me, because I haven't done these calculations. And so we're kind of brainstorming this together.
Yeah, I don't understand. Why do we add, Mandy, why do we add the 150 and the 75 together?
Okay, so let me see if I can break it down a little easier.
Okay.
300, you take 300 and divide it by 2, because that's the first half-life cycle, right? That gets you that 150. So now forget the 300. All you have right now is the 150 because the first half-life is 150. Okay. And then you take that 150 and you divide it by 2 again, because that would be the second half-life. 75 is what is half of 150. And that's the second half-life. And then you want to add the 2 together, 150 plus 75. And that's what gets you that 225. Because each time the first time the body lets go of 150. And the second time it lets go of 75. So you have to add the 2 together to get the answer. Does that make any sense?
Yeah. So like when it says 3 hours, that's actually 2 cycles.
Yeah, so you look at it from 12 to 6 is 6 hours total. So the first cycle would be 3 hours. How many cycles would you get out of that? You would get 2.
Okay.
You know that you got to drop it down twice in order to get the answer to the problem.
Okay.
It's a lot of
think
numbers. It's a lot of numbers. And it would, like I said, when she first read it out loud, I said, oh, it's going to get rid of it all because 150 plus 150 equals 300. But it's not that, because you have to realize that your body breaks it down halfway. So now the only thing left in there is 150, which means you got to break that down halfway too.
Okay. I'll just have to look at this more because I don't know. Thank you though.
Yeah, you're welcome.
Yeah, and I was going to say, like, this is just something that, and I'm sure I'm certain there's a better, like, in other YouTube videos that kind of demonstrate this. Like the way the way I'm thinking about this, and I'm trying to think of a good analogy, but I don't have a good one, and I'm just trying to pick off of what you guys are saying. So after 3 hours, so if we know the half-life for the question that we're discussing it's a 3-hour half-life. So half means we're going to take half of it will be gone, is what it sounds like the question is. So in 3 hours, 150 is gone. So there's only 150 remaining at that point in time. Then in another 3 hours, there's only going to be half of 150 remaining, which is the 75. And so that's what's remaining in the body, or that we've basically have lost we've lost 150. So we lost half of 300, then we lost another 150. So we lost half of the 150, which gives us 75. And then when you're adding the 75 and 150, is that saying that's how much is left in the body, or is that saying that's how much that was eliminated? That's where I'm getting hung up.
Yeah, that's how much is eliminated.
Okay.
Left in the body would be just 75.
Okay.
Eliminated would be when you add what you've like the 175 together.
That makes sense.
So I'm just gonna bear with me for a second because this will help me out. So here's how I'm gonna rationalize this. I'm gonna start with 300. After 3 hours, I'm sorry, I'm just gonna write 3 hours here. I'm gonna have 150 milligrams in the body, and I'm gonna have 150 milligrams, we'll just say gone. Okay. Then the half-life continues. We don't care. We know that half of it's been gone. So another 3 hours. What's left is the 150. So 75 in the body. Another 75 gone or eliminated. Okay. Then if the question is how much was eliminated, we're going to add these two together. The total eliminated is the 225 milligrams. I'm just writing gone, but that's easier for me to write than eliminated. Does that help at all? Like visualizing, like?
Yeah, I think so. I need to go over more problems, but
Yeah.
I think so.
And I will say that for this one, and whoever said this, and I agree with you, the answer should be 700 milligrams because that's how much was eliminated. Only 100 milligrams is left. The other thing you could have done here is if you only have 75 milligrams left in the body, 300 minus 75 would also give you 225 milligrams that were excreted. Does that make sense?
Yeah, it
That,
makes, yeah. Oh, sorry, Mandy, go ahead.
I was just going to say that just makes it a lot easier, way easier. So when you get down to your final number, subtract it from the very beginning. Will
Yeah,
that all
and that's what my mind goes to as well. And that's what I understand, like, because obviously not everyone does math the same way. And sometimes that gets a little bit frustrating. And then one of the things that I try and do is figure out what do you need to know and how do you need it explained in order to better understand it. So if you were doing it that way, if you were taking the total minus what was left in the body, and then the difference is what was eliminated, you're doing that correct. If you were adding both the things that were eliminated, that's also the correct way to do it. So there's two ways to do it. Both give you the same answer. And then just so you know, I would have done it that way as well. I would have taken the 300 minus the 75 milligrams, and I would have came up with the same answer, the 225 milligrams.
So just pay attention to the question. If it says eliminated, you know you're subtracting what you get from what you had to begin with. And then if it's asking you for what's left over, you just give them the number that you got.
Yeah, that makes sense why the first one would be 700.
Mm-hmm.
Right.
Yeah.
I like the way that, see, like, I wish that would have been so much easier for me to just be like, okay, so what's left in the body is 100 milligrams. Now we got to go back to see how much was taken out. Subtract it from the 800. Bam.
So let's do this 600 milligram one real quick, and then we'll call it a day. So half-life is 4 hours, 24 hours again. So I'm going to see if I can, I'll just leave this here. That's fine. So I'm going to do this without doing too much math. I'm just going to kind of do it like I did up there. I'm going to take my 600 milligrams. It's going to split into, after 4 hours, into 300 milligrams. Okay, so that's gone. This is still what's in the body. So it's going to split again. So remember, it's every 4 hours. So this is actually going to split quite a few times. So down now 150 milligrams, 150 milligrams. You don't have to do it the way I'm doing it. This is just for me to kind of help with visualization. Okay. Don't worry, I'm going to correct all this. So the first half-life was the first 4 hours, second 4 hours. So that's 8 hours. Then we're at our third 4 hours. So this would be our 75 again. I'm going to make this the elimination. So 75 divided by 2, I think that's 37.5.
Yeah.
So we've gone through, so 4 hours, so 4, 8, 12, 16. So we still got to do this 2 more times. So cross that out. I'm just going to start working myself this way. So 37.5 divided by 2. Someone help me out. I think it's 18.25.
18.75.
Oh, 18.75. Thank you. This is fun.
And then one more time would be 9.375.
Here we go. Isn't this fun?
This one is pretty ridiculous.
Yeah, I literally just pulled these from Quizlet. I think this is like from a pharmacy class. We only had that one example in class. So
no, I'm glad that you pulled these out. All right. So
ATI's like this, though, has ridiculous questions like this.
For Half-Life?
I haven't gone to Half-Life yet, but like for
There's no half-life on ATI, but no, I know what you mean.
but,
They have
but you
like,
know what I mean, like dosage by weight.
yes, exactly.
So if you're going, if the question was how much was eliminated, adding all these up would drive you nuts. So this is what you started with. This is what's left, right? The 9.375. So if I'm going to do this the short, sweet way, I'm just going to take 600 milligrams minus the 9.375 milligrams. And that will tell me how much was eliminated.
$590.
Yeah. So, and if you're being very specific, 590.625 milligrams was eliminated. But yeah, I agree with you. This looks ridiculous. It makes that 300 milligram one seem much more manageable and tangible. So yeah, practice those a little bit more. I hope this was somewhat helpful, at least for navigating the half-lives. And you know, I'll be back on with you guys on Thursday.
Thank you for doing this. Sorry I like threw this at you last minute.
That's all right. I appreciate the challenge. I just was trying to figure out like what the, like a lot of times the hard part is, what is the question asking and what are you supposed to be solving? So I felt like I could help you get to what was being lost, but I didn't understand like what are we looking for basically. But you, not a problem. I appreciate the asking the question.
Thank you so much.
You're welcome.
Thank you.
You're welcome.
See you on Thursday.
All right, take care.